How about now? Yeah, there we go. Okay.
So, welcome everybody to this WIP seminar. Today we have the pleasure and the honor to receive Blandine de Becker, who is a new PhD student in our center. She will present a talk called Epistemology of Models and Supervaluationism.
Exactly.
With super. Okay.
You got it.
Please go.
Thanks. So hello everyone, thank you for being here. First a little disclaimer, this is very much in progress work. I began my doctorate 2 months ago, so I'm sure you might have way more answer and information than I do, so any comment, any recommendation, any added value is welcome. The main idea behind all of this, I'm first going to present you a bit of the project I proposed 1 year ago with Peter. So the main idea we had was that, and all of this our question, we have a bit of literature about it, but that was the main project in the first place, which is changing a bit now that I'm getting into it. But the first idea we had was to work on modeling and idealization and supervaluationism. So 1 year ago we built a project about scientific models, thinking, okay, it looks like because of this problematic of idealization, models do not perfectly correspond to the world. We took the example of a climate model, thinking if you make prediction about how the climate is going to go, you need your model to be a bit certain, and on the other side, you're never certain of how you're modeling. We had this, maybe not intuition, but Peter read a bit about it, but it still had to be verified, but that you can model in an infinite kind of way, and because of that, you can end up with very different results, and even maybe sometimes in contradiction between two models modeling the same thing. So the idea was also to make it more clear about this intuition or maybe I shouldn't call it intuition, but this idea that a system that we try to modelize, so target system, I'll use this word during the talk, target system might not have as clear boundaries as we do in model, and the world might be way more vague than the way we represent it. And there might be a big contradiction between the binary nature of model and on the other side the world that is vague. So we have on our one side a model or models that are working with classical logic, and on the other side potentially vague concept. And a way to solve that would be to perhaps find a way to consider a multitude of models. For that, we are using the hypothesis that supervaluationist logic can address this problem. So the idea would be to resonate with the concept of super true, which I will explain a bit later, but which is the idea of something being true in every way you can make something more precise, which is used in supervaluationism. And to use the super true to be okay with using classical logic within model, and then using supervaluationist logic to handle a broader intermodal uncertainty. So we might end up, if this is working, with fewer conclusions, because for something to be super true, well, it's quite hard, but conclusions that are way more certain. So after checking a bit of the state of arts, but it was 1 year ago, a first idea of it, we really saw that indeed there is a lot of interrogation around the limits of model. There is a substantial literature about it and about the complexity of reality, and the fact that it's or the way it could be very difficult to be modelized. And there is also some literature about some solution for it through logic of vagueness, but none in supervaluationist logic. So, for example, fuzzy logic is addressing this problem. So the question that were there at the beginning were really, okay, how can we deal with knowledge obtained by model? How can we communicate when talking about model? Like, for example, with the public, we are speaking about climate model or climate in general, but are we really saying something about the climate itself or only the model? How do you take decision regarding that? And all of those came back to some very more substantial, deep questions, which are, okay, what is a model? What is the relationship between a model and the world? And what is the aim when using a model? So that was the first idea of the project. And then I ended up having to actually begin the project. So we were, okay, let's go. And I begin with checking a bit what's happening in epistemology of model. And therefore, today, I'm gonna begin with a little introduction or a bit of a point about all the stuff I've discovered through some articles, some author about the epistemology of model. This is a super complex question, so it's really only about, okay, what is happening in what I've read, what element does it give to me? What can I get from it to understand a bit more what is epistemology of model, without aiming for a very concrete, deep definition at all. This is just option, and I would be glad to hear a bit more about what is epistemology of model for you. Therefore, every time on the slide, I will make the main question that is interesting me into an article and the main information I'm getting from the article to understand better epistemology of model will be in blue. And I'll also explain a bit of the main points. After that, I will make a little introduction about supervaluationism, and then some opening about where supervaluationism look like it might find a spot, or where there is some little hints about, okay, there we see some vagueness, maybe supervaluationism might help over here. Okay. So let's begin. The first author I'm going to talk about is Michael Weisberg, and I'm going to talk about his book Simulation and Similarity, Using Model to Understand the World. So in this book, Weisberg is defining three main types of model concerning or in contemporary science. Mathematical model, computational model, and concrete models. I'm going to quote how he's explaining each of them right now. So mathematical model are abstract structure whose property can potentially stand in a relation to mathematical representation of phenomena. Computational model are a set of procedures that can potentially stand in a relationship to a computational description of the behavior of a system. And concrete model or physical object whose physical property can potentially stand in representational relationship with the real world phenomena. So the core idea or the main thing that is into all those models is that they are really interpreted structure and to address or to prove that this is a good way, a good typology of model, a good way to divide the different model. He's going to use two questions. Is it too broad? And is it too narrow? Too broad typology, too narrow one. So when asking, is it too broad? This way of defining the different kind of model, he's saying, okay, in the end, maybe you can say computational model might be just a special case of mathematical one. How come we have three of them? Well, to address that, he's saying that when you're aiming to understand how many types of model there are, you actually can ask three different types of questions. Either you can have a question that is more regarding the practice of science, so how many types of model scientists talk about. You can have an ontological question, which is what are model, how many type of this thing there is. And then you can have a more epistemic question, which is the question Weisberg wants to address, which is, in order to build an account for the practice of model-based theorizing, how many categories of model will we need? Here I'm quoting him. This is really the core of why he divided into those three types of model. It's because he's really aiming for an explanation. So he's definitely saying, okay, some philosopher might be like, we should have a more thin-graded characterization of model, have more type, and in the end you can describe a computational model as a mathematical one. But you'll miss something because here this distinction allow you to give an account of how they are used in a given scientific explanation. So it's really about how a model is giving any explanation. For example, and not for example, like for those three models, computational models are really giving an explanation in the transition rules or the algorithm. In mathematics, it's really all about the explanation that you get from the mathematical structure and the relationship among the variable. And in concrete model, you have an explanation because you can study directly the model and you don't need any mediation.
Can I ask, just to be sure that I understand, how do you understand the difference between explanation and representation? To understand Weinsberg? Because he's saying explanation.
Yeah.
Not representation.
No, actually,
okay. So how is he understanding explanation the same way we understand, or it's different?
At least he's speaking more about description just after, and he makes a difference between those two, telling you.
So what it is to explain for him?
I wouldn't want to give an explanation
just a clarification.
for
we
him.
Can discuss it later.
Okay, but this is definitely different than description.
Okay, thank you.
Then he comes with another question that will lead directly to description. He asks if this is not a too narrow typology, and he's giving the example of verbal or narrative models, saying that okay, people say that it's not mathematical, neither a concrete model. So maybe there is another model that is purely verbal. But actually those can really often be described as computational. It's just that you're going to express it differently. And there he's really making a difference between what is giving an explanation and how it is described. And you can have way more kind of structure of model if you're talking about description. So he really wants to differentiate property of the model description and the model itself. So for Weisberg, you have the structure that is giving explanation, the description, which is the way it's expressed, and then he's explaining third element in the anatomy of a model, which I'll not have the time to go deep in, but which is giving an interpretation for how the model is linked to the target system, which is also a very, very interesting element. In that part, he's more aiming for an answer for how to analyze the relationship between model and the real-world targets. So in the end, Weisberg really gives me information about the type of model that are used in giving scientific explanation, and then construal, so information about the link between models and target system and how you analyze it. So another source that is giving me a bit more of a hint about what is happening in epistemology of model is Katzav. Here it's treating epistemology of model, but in a more concrete field because it's about epistemology of climate model. The question he wants to address is what are, I quote, the limitation of 4 important views of what the target of useful climate model assessment is. But I'm not going to treat that much about his, the limitation he's seeing in those views, but more about the view itself, because that was a way to discover those views for me. So in the end, the question I'm interested by when I'm reading this article is what is the goal of a useful climate model assessment. So the first view he's presenting is the view defended by Elizabeth Lloyd. In this view, in the standard view, a model is successful. If a model is successful, the hypotheses of the model are confirmed. So the goal is really to know if a model describes the world correctly. And if a model works, you say, okay, those hypotheses are good. A second view he's explaining, so every time it's not the view he's sharing, he's explaining somebody else's view, and then a fifth one that is his. The second view is the adequacy for purpose view, which is defended by Wendy Parker. In this one, the climate model are considered as really being used to represent, and therefore they have representational goals. And so a useful assessment is to evaluate how much this model have an adequacy for a specific purpose, like explanatory or predictive purpose. The goal here is not then to confirm a model or to evaluate if it's good for a to evaluate if it's good for a specific goal, and so if it's in the end useful for the task you're using it for. Then the conservative view is confirming claim about the target system itself, and you don't have a result like, okay, the model is working, then we can be sure that the target system is working like this, but it's more a degree of confirmation of some affirmation thanks to the success of the model. There you really use a model as one tool among others, and the more something is shared by models, the more it's likely to be the case. The fourth view he's sharing is the Bayesian view. So I haven't read that much yet about Bayesian confirmation theory, so this is something I would be definitely interested by more explanation by you, but the way he explained it already is that one version of it is to say, okay, a claim is confirmed if its posteriori probability is higher than his prior probability, and here probability will be defined in light of the evidence, or not defined, but regarding the evidence. Then Katzav is defending the possibilist view, where he's saying, okay, actually, in the end, we shouldn't say that this is true or this is not, but that it is only a real possibility, and that you can rank possibility by saying how remote they are, but you should be a bit less optimistic about what you want to aim. And then, so what I learned about Katzav for epistemology of model is more, okay, what are the goals you can have for your model? So another article that is giving me information about the epistemology of model is from a more historical point of view, which has been, so it's tracing the development of model in philosophy of science by Daniela Baylor-Jones. In this article, I'm really interested into, and she's answering to the question, what are the shifts of interest in the treatment of the topic of scientific model? And then, it's really giving me an idea of what have been the goal of studying model through the last century. She's describing that there has been a switch first from philosophy of model, or from interest in model in philosophy, from being disregarded to being more popular around the 50s. This can be explained by the fact that by having more, in the first place, a logical empiricist movement that was considering model more like something aesthetic or didactic. And then there has been a regain of, or a gain of interest in model with philosophy of science. Then the second one has been from a formal account to more functional characterization of the models. Here you can differentiate two kinds of goals. So one, the goal A, that is aiming for more establishing a formal framework, saying what are scientific model in itself, and it's also more based on the logical empiricist tradition. And then on the other side, you can really be more interested into the pragmatic role of a model and their function and how they are used in the scientist enterprise. So it can be resumed as having a concept of model in a very general and universal way in goal A, and then having a diversity of concepts closer to the practice in goal B. The last switch she's describing is a switch from the role of model in science to the role of model in humane condition. And there, so in this role of model in human condition, model have been seen way more in their function of explanation, and there has been way more analyze about how model are building the way we think about object, about phenomena. So the information, what I'm taking from this article is mainly a shift in the use or even the definition of what is a model. Because I have an hour and we might be a bit short on time, and at one point we maybe don't want to see a lot of point of view and just repeat it over and over, I'm going to go quickly on this view and the one after. So just to be short, in Richard Levin's article, The Strategy of Model Building in Population Biology, there has been also a kind of explanation of different strategy of simplification of complex system and of model, which is I don't know yet if it's a typology of knots, and this is something we've been discussing with Peter. Like, is it more something you're gonna leverage? You make a trade-off, but in the end you always have something of the tree, or is it you have to choose between those three categories, but nevertheless here they are, and it looks already a bit like a typology. But in trying to modelize something, you have to make a sacrifice, either in the generality, either in the realism, or either in the prediction. This is an article made by population biologist, or I don't know if you say it this way, but a biologist that works on population, so that also has to be taken from that point of view, a more concrete one. And so that gave me three strategies of simplification, maybe three types of trade-off, or maybe not types, but just tendency. The second one I'm going to pass on very quickly is the article of Poznik, Michael Poznik, which is Make-Believe and Model-Based Representation of Science, the Epistemology of Prigg and Thon. I'm not sure how to pronounce those two, don't hesitate to correct me. In Thon's fictionalist view of modeling. So in that article, Poznik is explaining the fictionalist view, which I'm still trying to understand if it's really an ontological view, if it should be described only as that, or if it's answering to more questions, because it's really aiming to say what a model is and how it's working, and then he make an epistemological critique about it, saying there is a lack of account for how you translate an element from the model to the target system. So I find it very interesting to challenge me in my conception of what is more answering to the question of what is a model to what is the link between a model and the target system. Then the fictionalist view is saying that model is like creation of it's the creation of fiction. It's like it's a game of make believe, like a child playing with a stick of wood, saying it's a horse, and the only difference is that a model it's something that is shared by everybody, and this is why it's a fiction that looks a bit more objective. Objective? Well, I'm not sure I should use that word. Maybe, he speaks about objective imagination. The last article I will speak about, and then after I will stop just enumerating some typology, but I still find it very interesting, is the model in science, not article, but page on the Stanford Encyclopedia of Philosophy, written by Frigg and Hartman. So the aim of Stanford Encyclopedia is often to just give a broad view of what are the different view actually in the topic. So this is really, I'm really not taking that as a, okay, this is a Frigg and Hartman point of view. I'm more seeing it as a hint of how we can like separate the different kind of question in epistemology of model or in model in relation or philosophy of model in general. And I'm wondering how they did this repartition and how it can be compared to Weisberg's point of view and maybe to a lot of other stuff actually. But again, yeah, this is not their point of view, they are trying to give an overview. And the first question they are aiming to answer is something that they describe as a semantic question. What does it mean for a model to represent a target system? Here I see a question that can be somehow a bit linked to the question of description of Weisberg. Only there is also this question of meaning, but also in common of representation. And they enumerate a number of different kinds of representation that play an important role in the practice of model-based science. I was quoting them. Here you have them. We can go back to this after, but so model of data, scale model, idealized model, toy model, and so on. They're also then having a more ontological question, which they describe as a question in ontology. I quote them, what are models? That is, what kind of object are scientists dealing with when they work with a model? And here they explain the different point of view, which can be the skeptic point of view, anything can be a model. Model can be physical objects, they can be fiction, like we just saw with Frigg and Thon. They can be a set theoretic structure, they can be, and they can be a description. Here I see something a bit close to the question, the ontological question of Weisberg, but at the same time there is some common element with his question about his more epistemic question. So I wonder how, what's the dynamic between those two? Is it that some ontological, when you say that a model is something, it's also saying something epistemic about it to still be determined. Don't hesitate if you have any information about that. And then the last question they're asking is more from an epistemic point of view, which is what are the cognitive functions that model perform? And there it looks like a very common question to also an epistemic question, just like Weisberg. At the same time, it's really aiming for something else in this epistemic, in all those epistemic questions. And it looks like a bit closer to the answer of Kazaf, which were more aiming to understand the goal of modeling. So you can have models that are there because you're learning about model when constructing them and when manipulating them, so a bit close to the standard view of, that Kazaf was explaining. You can use model to learn about the target system, and then there is the question of when a model does represent, is it really saying something about the reality, or is it really instructing you something about the reality? Does it really describe some part of some aspect of the world? If you take that point of view, it might be very close to the third view, which is conservative view of Kazaf. When you're using model, you can also try to explain with model. Okay, do model explain because or despite the idealization they have or they involve? Does having a model that is a bit more realistic involve that it's going to be a better model or not. You can also understand with models, so it can allow you to have a better understanding of the phenomena, and then you can have some other cognitive function like constructing other model and generating a new target system. So that's it for all the epistemology, not all the epistemology of model, or not all the articles I've read about epistemology of model, but the ones that really look like giving me interesting, at least on my point of view, interesting information about what is treated in epistemology of model. But okay, this is only 6. Epistemology of model is super broad, and I still have to read a lot. So one of the limits is that this is not that much author. Author as Weisberg, such as Weisberg, Katzaf, are really using some example of model to prove something about it, so this also has to be considered. Thus, giving example is really saying something precise and that you can believe, or is an example, not a proof. Maybe I'm too logic for that, or I don't know. And my sources include scientific and philosophers, so this is also something I have to check regarding is it an analysis made by scientists or or philosopher? And Alexandre mentioned, and I think you mentioned, that this is something that has really been a switch in epistemology of models, so this is something I should go deeper in. And it's also coming with a lot of questions, like, okay, how can I account for those different limits? What's the difference between Weisberg and Stanford's encyclopedia conception of ontological question, epistemological question, and semantic or description question? Why does it look like those questions overlap? Is it because it's like in those different fields, but treating about different questions that overlap in different fields? Also, does it make sense to be interested in specific field like climate model when I'm trying to study epistemology of model in order to develop a new view on models results, knowing Supervaluationism? Can we really make a difference between ontology and epistemological point of view, like for free and tone? Is it another subject than the epistemic question that Poznik is answering? Then the question Poznik is having. And how did the Stanford Encyclopedia made this delimitation in the different question, and how did it make the different typology of model in those questions? So to make all those elements a bit more clear, I tried to do a little sets of questions. So here you really have an overview of the elements that are studied in the different article or book, but I'm not claiming at all that it's their opinion so far. And
just to be sure,
yeah.
So you read Poznik about Frege,
yeah,
but you didn't read the Frege-Thun position?
Not yet, exactly.
Or the more recent, okay.
No, that's the plan.
Okay.
I would like.
Because I will not read Poznik, but
yeah,
I will do it with Frege first.
Yeah, that makes sense too. I think.
I would not read Weinsberg also, but I read this dissertation 20 years ago. It's okay.
Oh.
Never changes mind.
Could you tell me?
Sorry. It's for the question period, so please.
Okay. But that's also a limit. Reading somebody about somebody else, it's not like reading the first source in the first place, and I should have maybe begin this way. And I will.
No, but it's just because Frege is so radical compared to everything you've written. Maybe it would be more interesting because you would have a complete different way to see models than all these guys.
Okay, then I'll add it on the list definitely. Thanks. And so this is more a long-term goal of it would be to have more maybe precise characterization of the different point of view, and to have see who is defending what, and maybe the question might change also, who knows. But so far I'm seeing 3 types of question that comes a lot. And the 2 and the 3 are like the name are really based on Baylor-Jones differentiation, like pragmatism and formalism. The first one is more a question of do model correctly describe some target system? So a more realist question. Also, if you have any comment about the name, like that's how it came a bit, but I'm really still discovering stuff, so don't hesitate to tell me, no, Blandine, you should call it this way, it makes no sense, you are doing a mistake there and there. Like, it's only a potential. Then a more pragmatist point of view, what is the role of the model or of models and what are their functions? And then something that is more about formalism or model good tool for systematic prediction. Yeah, we talked about that name with Peter, it's still a bit to be determined. Then, more than the question that were being asked, I also saw a lot of typologies of models. So I was like, maybe we can do a typology of typology. So that was not a typo in my description. It's really like trying to have a type of models. And one way I see that it's often described is either through semantic or more, even though this is different, but there is a common thing in those two questions. So in the semantic and descriptive question, what are models meaning and what are they describing? And here we have put the different type of description that Weisberg is seeing, even though what he means is that you can have a lot of type of description, so etc. And then all the ones that are quoted by by Frigg and Hartmann in the Stanford Encyclopedia. From a more epistemic point of view, how do models relate to the scientific practice of knowledge? Is it that they are giving different explanation from a mathematical, computational, and concrete point of view? Does it give information about, or is your typology giving information, as the second one, about the cognitive function of model? Or is it about the goal of using a model, like in Katzaf? Do you have a more pragmatic or formal aim? And then the question is, does that typology is a typology, so should it be there to be determined too? Do you sacrifice generality, realism, or precision? And then from a more ontological point of view, which I really didn't want to go in metaphysics with that project, but it looked like those questions are there anyway. So at one point you're gonna see them, and I still have to say that there is typology speaking about it, and I will encounter some. And then do you aim for a very in the question, what is a model? Do you aim for a universal concept, or are you okay with a diversity of concepts that are more respecting the scientific practice? And then what do you think it is? Can it be anything? Can it be only physical object? And so on. So those two, maybe I went too deep, don't hesitate, but those two, this typology and those sets or this diagram, I wanted to put them together, but not to put some name in it already, because again I have to see way more what are the point of view of the author and less what they are mentioning. But I thought putting them on two axes to have another type of typology might give a good hint of where I should go for further reading, having maybe a conceptualized schema of it. But this is not clear yet for me. I also have this intuition that there might be a correlation between the two types of question you can ask, but not sure at all. If you have any inspiration, don't hesitate to. Voilà. Okay, now that we are done with that part about epistemology of model, now that you have seen a bit more what I've seen so far in epistemology of. You have had some information about epistemology of models. We can go a bit deeper into, or we can just go in supervaluationism, and then I will make some opening about where it might be that supervaluationism find a spot in epistemology of model, but this is still very unclear. Again, a lot in progress, but getting there at one point. Okay, so supervaluationism is a type of logic of vagueness. You don't need to read all of that. That was if somebody was interested into the demo, but it's pretty chill. It's the Sorit's paradox. For a little reminder for those who don't deal with heap all the time, the Sorit paradox is a paradox about the grain of sand, which is being paradoxical because it's being paradoxical if you accept on one side on one side that 1 grain of sand is not a heap, that 1,000 grain of sand or 100,000 grain of sand is a heap, and then on the other side that you don't have any grain that is going to make the difference between a heap and a non-heap. Often the metaphor of bald man is used. Is there really one hair that's going to make the person that you're going to say, okay, when this hair is gone, then you're bald, and not before. And because of those two concepts and classical logic, you end up with something paradoxical, because you can make a demonstration with having first 1 grain of sand, which is not a heap, then going to 2 grain of sand, which is not a heap, and going over and over and over until you have 100,000 grain of sand, which is not a heap. Because you base yourself on a principle. In the Sorit paradox from Holmes and Zardini, they use 2 different types of principle to explain it. I think there is plenty of them, but here are 2. First, something that is more linked to contradiction. Would be for each grain of sand n, it is not the case that n grain are not considered a heap, and that n plus 1 grain are considered a heap. So use that every time you add a new grain, and 1,000 grain of sand, which is not a heap. You can also use the notion of tolerance. So instead of saying it is not the case that there is this difference, you say that for each number of grain of sand n, if the number of grains n is not a heap, then the number of grain n plus 1 is not a heap neither. And because every time you tolerate it, you end up with not a heap, with a giant heap. So, supervaluationism is a type of solution, a type of logic trying to deal with that sort of problem of vagueness. Which is a bit of a special one because it's between classical logic and not really classical logic neither. So this is also very new for me, so don't hesitate to...
Oh, sorry, what's the little...
Oh, sorry, Max. Indeed.
I might be the only one who doesn't know that.
No. We've all been at a point where we didn't know, so it's a no.
Okay.
Do I say it right? Not the...
It's not.
Not.
Yeah,
Okay.
Negation.
Thanks.
Let's make it this way. So Peter talked a bit about supervaluationism 2 months ago. I'm gonna take it from a more like another point of view, but it's not applied to model yet at all. So you'll see. So supervaluationism is saying that there is indeed some short boundaries. There is indeed one point where you go from non-bold to bold, one point where you get a heap at that grain of sand. The only thing is that there is not one particular n such that both n and not n plus 1 hold. So you don't have this specific grain that is a specific number. An example that is used in the Sorit Paradox book is, you're going to have 20 days of holiday next week, you just don't know where they are yet. And maybe Christmas is going to be for sure a holiday, so this one is pretty clear and it's like the big heap, but the rest, it's a bit blurry. Supervaluationism does accept that every sentence is either true, either false, but not both. That 1 grain of sand is a heap, and that 1,000 or 100,000 grain of sand is a heap. It does accept principles like the principle of tolerance I was speaking about just before, and it's accepting that there is it's accepting the claim that there is indeed a n such that n and non-n plus 1 is true. But even though that looks contradictory, it's not contradictory because of a little element that makes the beauty of supervaluationism, is that true does not mean true in all processification, which I'll try to pronounce good.
That was spot on.
Yeah.
As a native speaker, I get it wrong all the time.
So processification is a way to make something precise in all the vague, make precise all the vague predicates. So the aim of supervaluationism in all of that is to preserve classical logic, the structure of the vague predicates, and the indeterminate character of borderline cases. To try to make it a bit more clear, I'm gonna give again an example that's coming from the Solid's Paradox book, an example of processification. Oh, there was one C too much this time, sorry. So let's imagine Franca is older than Bianca, and you want to make the concept is a baby more precise. You can say that Franca is a baby, but not Bianca. Well, this is not a good way to, or this is not a reasonable way to give a processification, because Franca is older than Bianca, then if it's a baby, Bianca should not be a baby. But if you say, if Franca is a baby, then Bianca is a baby, here it is true in every reasonable way of making is a baby more precise. So you have two ways of making more precise. You can either say that a sentence is true if it is true in some way of making the vague expression more precise. So if it's true in one situation, I should not use this word, but in one way to make it more precise. Well, this is good. This is all we need to say it's true. Then this is a structure. You don't have that much. You don't ask for that much to make something true. And this is subvaluationism. But we are interested in the other valuationism, which is supervaluationism, because we are aiming for the best. Then there the sentence is true. Just if it is true in all the way of making the vague expression more precise. Okay, so how can all of that, and maybe is a bit too much for today, but how could maybe supervaluationism give, or where could it maybe find a spot in epistemology of model? Where do I see that it looks like there is some question that could be addressed by supervaluationism in what we've encountered so far? Well, in Weisberg, he's definitely talking about something that looks like similar, because he says that multiple non-equivalent model, there is multiple non-equivalent model if there is any, no, sorry, I take it back. So you're gonna have indeed some a multitude and non-equivalent model to make something more precise. You have you have multiple model if there is any vagueness. This uncertainty affects how many models the description is associated with. So here we see that sometimes one model is not enough, and that you then use others. Does it mean that you need a multitude of models which could maybe be compared to a multitude of ways to make something more precise in a bit of the same way as vagueness or supervaluationism? Weisberg is also saying the structure are not present in the real-world phenomena, and the modeler just make decision about which aspect of their model they encounter for, and so are taken seriously, and so thereby we see something that was also in our hypothesis, that there is a choice about which stuff you want to make more precise, which element do you integrate in your model, and that then if you want something that is closer to the reality, maybe you would need a multitude of models. That show also that maybe model indeed have boundaries that are way more sharp than what the target system have, and that we should give an account for that. Levin's then is saying that, again I quote him, that there is too many parameters to be measured, so some are still only vaguely defined. Here we really see that systems are too vague. How can we represent it? Levin is also saying that if these models, despite the different assumptions, lead to similar results, we have what we call a robust theory, and that true will be in the intersection of those theory. But then here we have something that could be maybe close to super true, something that is true in all the precisification is something that is super true, and then what about something that is at the intersection of all the models? Maybe it means something else. Baylor-Jones is quoting Hutton saying there can even exist multiple models of the same thing and they overlap. Here it's the same idea, what about this overlap? Baylor-Jones is also quoting Hutton saying there is always some element that is changed or left out in the model as compared to the thing of which it is a model. So again, when you modelize, you leave some stuff outside. Should you not give a lot of different kind of model to make something more precise or make the target system more precise? Then there is also some hints in Katzaf's work. So model try to establish that the prediction describe real possibility, and there is a rank. You can rank the possibility as to how remote they are. Then this view of Katzaf possibilism, could it be that it's all the model that's or all the possible way to think about a model is actually making this vague element, the target system, more precise? Could it be compared to a possible precisification? Is it that if you have higher rank possibility, maybe it's higher, it can be compared to a higher truth, and then if something is true in every possible world, you can have super true? Then Katzaf is also talking more about it in the standard view, with saying that there is intermodal agreement to warrant increased confidence in model results. That means that maybe an intermodal account with agreement of what is true in a multitude of models could be used, as in supervaluationism. And then again, success will have to be among those assumptions that are shared by the model used. And so if something is shared by a lot of models, could it not be compared to precisification in a lot of cases? Okay, so that was really like more an opening and some hint of where I see it. But of course, I'm not saying there are those authors are saying this is super true or we're using supervaluationism, but to check deeper. And all of this come with a lot of question. Where supervaluationism might find his spot in the typology I was making. How can we apply logic to a topic that is so much not logic? Like, how does it even work? I don't know yet. We'll determine it. How could I have a more precise goal regarding supervaluationism in that in epistemology of model, in theory of model, like, okay, say, let's use supervaluationism to resonate about it. It's nice, of course, logic make like resonate about stuff, but what would be a more precise question about that? Where do I want to go with this? And some question of comprehension. I'm sorry in advance because in Weisberg epistemology, I'm not quite clear with the difference between the explanatory power of computational structure and the mathematical one, and I still have to do some research regarding the understanding of set theoretic structure view of models. So if you have questions about that, sorry in advance if it's not perfectly answered. Thanks a lot.
Take 5?
Yes.
Question, comments? Victoria?
So, thank you for the talk. It was a question of clarification about supervaluationism. Supervaluationism is equivalent, I don't know how to pronounce it in English. Like you have true, super true or not super true. Do you have a possibility of like ranking, like this is more close to super truth than this stuff or not? I don't know if my question is clear.
So you mean, can you say about something, this is more super true than this thing is?
I suppose you cannot say that something is more super truth because it has to be like, but it can you say like it's more close to super truth than other things?
I don't know if it's done. So I haven't deep dive into the application yet. I would say this is maybe closer to fuzzy logic than supervaluationism. So I haven't seen it yet, and I'm not saying it's not there. But maybe you can say, okay, in that case there is more way to make this more precise, that make this element true. But I don't know if it's something that is really done.
Okay.
But yeah, indeed, super true is true in every case. So it's high standards. Who knows? Maybe we can build a fuzzy and supervaluationist logic together. Maybe it does already exist. Maybe we should do it. But who knows?
Okay, Asa?
I actually had exactly the same question.
Okay.
And it seems to me that at some moment you did say something, like in the end you say something like, when you started discussing different, like showing different quotes from authors and saying it's something like supervaluationism, you said something like you can classify truths, something like this, and it seemed to be like a natural idea when you read this modeling literature, is that the point they often make when they talk about robustness is that, okay, we can, like, we did one model, then we did another model, and it gives the same, so it's a robust finding, so it's better. But I think they will also say something like, but it's never like we exhausted all of the models, and now we say, oh, it's actually true with big T. So I think there's this sort of tension which Victoria just explained, that if you use super truth and this sort of hardcore supervaluationism, it will mean that you will have to sort of claim to exhaust all the models. And I was just curious whether, like, what do you think is the direction to go? Is it to do this sort of ranking between different sorts of, like, I don't know, different truths, or?
Thanks for the question. So last year I explained the project to some engineer colleague, and they were like, yeah, but if you say in the first place that you cannot have access to everything, and then you say it's super true, you indeed have a contradiction. So this is definitely one of the question I have. But at the same time, if you say, okay, this is all the way you can, it has been modeled so far, and something comes back in every way to model something, then so far it is super truth. Maybe there is this element of a super true being, like something being super true until maybe you make a model that is contradicting it. Maybe I should use fuzzy logic to add to this. But for now, yeah, the idea was to use that tool. But then, indeed, I think at the end of the different explanations, sorry. Yeah, I think here I was saying, in possibilities view, you can have higher rank of possibility, and does it make that you can have higher truth and less higher true? Like, this is definitely something I'll have to address at one point. Or will I be interested only in things that are true in all the models that are there so far? I don't know yet, but that's a potential
like,
problem.
I know much about the literature, for example, about climate models, but it seems to me that the case is like 15 out of 16 best models predict this, and then one of the 16 model doesn't predict, I think for scientists this will be not that different from the case when they had, for example, all the 16 confirming, or they haven't had the 16th, so they had only 15 and they all confirmed. I don't know if, like, it seems to me that for scientists this will be almost equivalent cases, but I think if you're indeed sticking to this idea of super truth, you will sort of be obliged to differentiate between cases.
Just to add something about this specific example that could be interesting for you, it's the book of UCLouvain, who was a postdoc here, because what the scientists in climate science would do is that this model has a weight of 3 because we have confidence in it. This model has a weight of 1 because we don't have confidence. And you do some kind of weird average, and that's the thing.
Yeah.
Which is super bizarre when you think about it.
I wish Peter were here because I'm digging back to my modal and multi-valued logic course from my 3rd year of undergraduate.
A long time ago.
Which was a long time ago. But my recollection is that, I mean, right, there's a natural way of reading supervaluationism as a kind of pseudo 3-valued logic, right? You know, you get the super true stuff, you get the super false stuff, and then you get the stuff in the middle stuff, the gappy stuff. But my recollection is that this intuition that you were playing with about, like, doesn't it seem like you could kind of rank stuff as getting closer to or farther away from being super true? My recollection is that the standard way to pick up that intuition and run with it is that's what often motivates people to go to infinite value logics, right? To go to real, not real value, truth value.
To connect to Bayesian logic.
Yeah, exactly. Like you start to move in that. If this intuition really gets you, then I think the standard technical response would be like, okay, the tool that's right for that job is just like, so say the truth or falsity is a value between 0 and 1. And those are well worked out logics too. But then you do break this pretty connection between, you know, the collection of models and supervaluations. I mean, that is a nice analogy that, yeah, I mean, if you say, okay, let's just go to infinite value logic, well, you break it.
But in the end, I think the connection I'm making with supervaluationism, you can also most of the time make it with fuzzy logic, which I guess infinite value logic is a kind of fuzzy logic, but that is really with an infinite.
It doesn't have to be.
No?
No, most of fuzzy logics have to be finite, and you have to define exactly what you use in the set, and not just infinite values between 0 and 1.
Okay.
In fact, there is a thesis which aim to combine supervaluationism and fuzzy logic in computational science. In Vienna, I have the PhD thesis, I can send to you. The first part is on to the tenor, the way to understand the tenor in fuzzy logic. The second part on supervaluationism, and the third part on the evidence of the two. And it is the set of the classifications that is used to fuzzy. Yeah, it's not the value for the fuzzy logic are the set of classification in the supervaluationist logic.
Okay. Well, we can combine it. Let's go. Okay.
Other questions or comments?
Coming in from online. Says, thank you very much for the presentation. Could repeating a simulation several times help like change the way we think about super truth? You mentioned climate models, and it seems that climate scientists work a lot like this. They run many simulations and many models, and then calculate the statistical averages of the results. It's a risk approach, and they say, see Modeling the Possible. There's a chapter by Joe Russos in Modeling the Possible.
Okay.
And who is the speaker?
I have but a pseudonym.
Okay.
I think it might be Marco. But I have but a nickname.
Okay, so the main question, you said it very quickly, or can you read it a second?
Yeah, so how does running the simulation lots of times factor into this?
I think, yeah, simulation and model are definitely some different topic.
It is Marco.
Sorry?
It is Marco.
Ah, okay. Great. Hello, Marco.
Marco says hi.
So I wouldn't want to like already say something about something I haven't read at all. Even though, okay, indeed, Weisberg is calling his book simulation, and so it is linked. I guess it depends, because the first idea I have of simulation is something, so you model something and then you put information in it and then you run it, but maybe it's because Marco is talking about running a simulation. But maybe it is that when you put different information in it, regarding how you model it, you end up with different results. I do not know. I haven't read about that yet. Maybe somebody have read on simulation and can define it. Maybe
I'll type out the citation that maybe just as Marco says, maybe just think about just computational models instead of simulations.
Yeah, okay.
But there was a reference in the comment that I will copy paste and send to you.
Perfect, thanks. Okay, wait, I'm thinking about it for 2 seconds.
Other questions, comments? Is that?
Yeah, it's so. I'm just thinking now that. Do you think it's like? You said you want to focus on models in climate science, but then you were talking more generally about models, generally about models, and I'm quite generous there. So, but do you think there's a difference between sort of different sciences and different sort of reasons why we do modeling, and which may be important for whether you want to use supervaluationism or not? Because like I know almost nothing about climate science, but it seems to me like if you want to do a model which then somehow should instruct policy, it should be different from when you do a model for fun, or I don't know.
Okay, yeah. Thanks. Let me know if I'm not answering right,
Yeah.
but from what I get of it. So when the main idea of the project was regarding model in general, and then climate model was an example of, okay, there we really have an important aspect of it. Here you will have a lot of consequences regarding how you deal with that, and how you can be more precise or have more concrete results. Then I read Kazaa, and I was like, okay, but are those views you only have in climate model or not? Then it looked like very similar to some view explained in cognitive function of modeling. So I would say regarding that there is a similarity. For example, like between epistemology of model in general and epistemology of climate model regarding how they are defining model, or at least their use of model. But Kazaa is really saying you can defend either that. And I'm wondering if epistemology of model is not saying in general you can have all those different points of view, and then once you go in one type of precise model, you have to choose how you interpret it because you're more in something concrete. I'm not sure about that, I have to check. And then regarding supervaluationism is it answering to somehow the question you were asking?
Yeah,
okay, perfect. And then regarding supervaluationism, well, indeed, first we saw it as a potential solution, but I don't know if it was climate model that came first, or I think supervaluationism came first, and climate model was a good example because also like it's so important for sure, and so you use it easier. But now talking with sometimes some philosopher of climate model, I'm not sure this is really mainly for this problem, this kind of model that supervaluationism is the more interesting. I'll discover it, but it looks like maybe for climate model, fuzzy logic is making more sense from but well, I had this discussion with Julie Jobelin. Sorry for my mispronunciation. And she was saying, indeed, fuzzy logic may be more sense, and so it might be that it's not the same type of model I will want to address, or not same type. Here, it's more about the subjects, but then you also have.
This chapter from that Marco was recommending too may be helpful, I think, for thinking about the way that climate models will factor into this kind of thing. Because I think what Marco just recommended is a chapter describing the methodology that Alex Onkel was talking about just a second ago. Yeah.
Okay, I'm definitely interested.
But Julie wrote the book now, so we can.
Mm-hmm.
No, nice.
Yeah, it's also on the to-do list. And then also you have so much type of model like this, like which part of the world do they try to describe? Maybe doing.
Yeah, but that's a comment I wanted to say. This list, it's coming from science.
Okay.
Okay, the other list you provide until now, it's all lists produced by philosopher. But this list, it's the way physicists talk about model.
Okay.
Scale model, analogical model, idealized toy model, minimal model. That's a physicist's taxonomy, which is not necessarily the same that the goal of a philosopher to do a taxonomy.
Mm-hmm. Exactly.
So it's not for nothing that Frege and Hartmann comes from philosophy of physics mostly. Yeah.
Okay. Well, thank you. It's super helpful. Like already making it more clear how they do this revision. Yeah. Then let's say more regarding which subjects or which type of model I go in. Maybe supervaluationism will be way more helpful for something else to also be determined. Or I'm gonna, sorry.
Thanks. I have a very general question, but how does the project and specifically this about the epistemology models relate to, if at all, to the literature on the role of values in handling uncertainty? I know, I mean, it's the classic Max question.
It's the Max question.
No, it's a good question. It's just she's a logician, you know.
I know.
They don't even talk about real science ever.
No, but so no, because there is some literature on I think Weinberg contributed to this of sort of values in climate models and the role of values, not valuation, this is supervaluation, but values, which I don't know if they are related in any way. Are you going to address that literature or not at all? Yeah, that's it.
Okay. It was not in my first plan. Like, do you know anything about the role in value? Like, can you, because it's a whip, I'm like, maybe you can answer the question, perhaps? Or
Not so much as
Enter Douglas?
not so much in models, but the idea that non-epistemic values play a role. For example, risk plays a role in sort of how we understand what model to prefer. So as I understand it, is a way of thinking about if we have two models or 6 models that say one thing and 5 models that say another thing, how do we make a policy decision when time is limited, resources limited, in specific context, and so this kind of stuff, which feels like it might be in dialogue with this, how I understand this supervaluationism, but is because so is supervaluationism logic a way of saying things are not true all the time, but when they are, they're like super true? Or not at all?
well, if something turns out to be true in all the way you can make it more precise, then it is super true. So I also talked with Peter the other day, and I was a bit lost about, okay, but this is logic, and then you used it in your talk 2 months ago, talking more about indeterminacy, and he was saying, yeah, it can be expressed in a lot of different ways. So, for example, here we're gonna say, okay, all the possible way you can make it more precise, or you're gonna say something about the true. It's gonna, the super true or not super true. If it's super true or not. But then it doesn't have to be in all the way you can make it more precise. It could be that it's applied in another context. But I wouldn't disagree 100% with what you said just before. Can you just re-say it?
Well, about the relationship between supervaluationism and the values in science?
No, sorry, about the sentence about the
I
super true.
I was trying to understand it in my words, so I wrote, yes. Things are not, so whatever claim you make is that it's not going to be true all the time, but in some contexts, yes. And then when it's so, then it's really true, or you're super sure, but I don't know if this is like what you're actually saying.
So that's the point. Like, first time I saw it, I was like, okay, but there is another solution to the paradox, which is contextualism. And which is saying, okay, depending on the context, it can be true or not. You have to check at the context. But this is not what supervaluationism is saying, and this is where it gets very tricky. It's more all the way you can make it more precise, like all the truth value you can have in not all of those cases.
But on the other hand, the grain and sound, they are not ambiguous.
The
grain, there's one, there's two, there's three. It's not ambiguous. It's in the mind of philosopher that there's a problem there because it's not in nature. It's not like fuzzy stuff for there's one, there's two.
But it's not the grain that is vague. It's the heap that is vague.
But why use the word heap?
Well,
that would be a good reason for me to stop to use the word heap or mold.
This is my other question. When you mentioned ambiguity and uncertainty, is it ambiguity in the relationship between the reality and the model? Like this case about like heap, is it a heap or not? Or is it uncertainty about how to handle different models?
I used ambiguity because ambiguity for me means that a word can have two different meanings. So I shouldn't be using it this way. So this is the difference with vague.
It's a question of like, it feels like it's something different between this idea of like, is it a heap or not? But this is there's ambiguity in itself, in that problem of like, when n amounts of sand are a heap. But it feels different than when comparing different models. It's about uncertainty in the comparison, not in the relationship of those models to their supposed reality.
Yeah, but so when you have something vague, it can be vague regarding. So a mountain, for example, it can be a vague concept because you don't know when you're gonna say something is a mountain. But you can also say it's vague because you don't know where the mountain begins. So I would make link with that. This is two different ways to be vague. And here, what do I want to address? Well, I'm not saying that the model is vague itself. I'm saying that, no, it's the model that is a bit not vague enough regarding what's he's trying. So actually, Alexandre, maybe, but this is an hypothesis. I wouldn't say I'm like, saying this is true. It's more like an hypothesis for this work. It's to say we assume that there is somehow a bit of vagueness in the system itself. Maybe this vagueness is coming from, when we want to talk about only one element about the system.
Because I thought that supervaluationism was to manage the vagueness of language, but not in the system. I'm confused now.
It can be on different levels from what I know. And Peter was aiming for more
in the system itself.
No. His project, when he talked about it,
but it was in the system, but it was not for models. It was for quantum properties.
Yeah.
So in the quantum properties, I can understand, but in a model of a classical system. But okay.
But then it's
I
not
will
in the
ask my
model.
question after that about
Okay.
where is supervaluationism because I'm confused.
Me too.
So finish
Okay.
the question.
No, that's it. No, that's it.
So the vagueness is not in the model, but more in wanting to, or is it in wanting to represent only one part of the world, or is it on the world itself? That's another question, but on the system. And is it vague because you say only this is a system and it's not only this, and it's always a set of stuff, or is it because it is in itself vague? That's another metaphysical question. And for the value, thanks a lot. Yeah, that would be, I'm gonna check that out. Maybe it can be another way to, like,
And we will have it third class.
yeah.
Specialist the value.
Okay,
of
let's
value
go.
in science.
But then on the other side, like, I have to be careful with. I know in the beginning I was saying to Peter, maybe I can really model it, then after and begin to code and so, and he looked a bit like you have to make the difference between going very concrete and not, and then if it's like regarding decision making and so. Yeah, I have to not get lost in that neither, even though it's so interesting because like it's more the concrete aspect, but yeah.
But maybe just add some, if you don't interact with it, maybe have a way to deal with it. Like, well, I don't deal with it because of X. And then I think, I'm sure that's a legitimate way of handling it.
Okay, thanks.
Okay, other questions or comments?
I'm still formulating mine. You can
Okay.
go.
So I can just, you ask a lot of questions for us to help you, so I have a few, and I have maybe one or two questions. One, it's true that Weinsberg is not clear about what is mathematical computational simulation, so go to read Paul Phrase, who wrote a book just on that, and it was before
Who? Sorry.
Paul Phrase.
Okay.
The book about computational science. And it's very clear and very convincing. There's after that a debate that you can read between him, Paul Phrase, and Frege, and the guy about causality. I have a blank. But that that push Paul to be more precise about what he was saying about the status of the difference between a simulation and a computation, the difference between an equation and a computation, blah, blah, blah. Rice Frege wrote a paper against Paul, and Paul answered. So that helped a lot because this is really confusing in the literature about model. They don't make the difference between all these different things. I can say to you that don't worry about the ontology of models. Why it's present in the literature is because the people that started the semantic tradition of against the axiomatic, they wanted to say it's non-linguistic. Model can be non-linguistic, and it was very important to say what they were. And so, but you don't care. Also, it's still a little bit important for the people that believe that models are representation like image. Okay, they are like, so they say model are similar or model are isomorphic to the world, and they have to say how do they mean by similarity, so they have to talk about what is a model. But I think for your project, you don't need to go that deep. At the beginning of your first slide, you said idealization, but after every example looks to me as approximation. It's not the same thing. So go in the literature on Batterman and Norton. The difference is subtle, but for a project like yours, it could be different. Between an approximation is a false model. It's a false representation of something. An idealization is a true representation in a possible world. So it's not exactly the same. Okay, my question, because I was confused if you made a strong difference between the empirical part of a model and a non-empirical part. Because I can understand your project as talking about the empirical prediction of our model, or maybe something more, like when you talk about true, correspondence true, for example. Because if you stay to the empirical part, I see how it's easier maybe to build your project. But if you want to capture also when people talk about explanation or understanding, which usually implicated more than just the empirical part of models, which would be interesting. I have more difficulty to understand how supervaluationism
Supervaluationism.
yeah, will manage the non-empirical part of model, especially since two models, as you said, could have exactly the same empirical prediction but be completely different in their non-empirical one.
As in the way you're gonna use it.
No. You can say Lagrangian and Hamiltonian model, there's an isomorphism between the two, but their explanatory power is completely different, but their prediction is exactly the same. So people in the model tradition, they are very careful about that, because since they want to capture understanding and things like that, the variety of models, the fact that model can be transformed in other model, it's really important. And it's Frege and Thun, when they proposed their, and the model they propose after too, which is called an abbreviation, I forgot, ISIC, isn't the ISIC technique? This is really important. For them, model do not represent at all. They are just inference tools, so we should just stop talking about similarity and stuff in the world. And models are there to help us, but they are not.
Hence why it's crazy radical, obviously.
Yeah, but
Saying
it's pretty close to practice. In fact, what is cool is that it's when you say, okay, models are not image of reality. You look at what people are doing, and in fact, it fits pretty well their model. People are trying to build stuff that predict, that goes from model to model. They do analogy with model easily because they don't have a very substantive vision of what is a model. For me, Frege is closer to practice than a lot of people writing about models. Because he's describing models for professional, not model in textbook, where you simplify and you say, there's the pendulum. The simple pendulum looks like a pendulum, and blah, blah, blah. But climate science, simulation, these are very complicated models, where the distance between what you represent and what you do in the model is pretty far.
Mm-hmm.
Especially if you do something like an averaging of model. And when, Azat, you were talking about this averaging of model, it's not just different model on the same thing. There's a guy doing the model in North America about the North American continent. There's a guy doing a model about the weather pattern in the Pacific. We'll do an average between the two to have a global model of the world. That's pretty far from a picture. So I was just asking to you, do you consider that the project is more about the empirical part of models, or maybe models, every aspect of the model is used to represent?
Mm-hmm.
Because there's surely in models part that are not just empirical.
Mm-hmm. Well, furthermore, even more since when you say empirical, it's really comparing your model to what you're saying, what you're seeing.
No, not to the thing, to data, which is not the thing.
Yeah, not even.
It's like I wanted to ask you, what do you mean by phenomena?
Oh, sorry.
Because that would be important for the project.
Yeah, I was quoting, but
for you, is it just the empirical part, or it's more than that?
For me, that far, yes. And when talking about it, like here I went a bit outside of the empirical question to also have a broader view of what is said in epistemology of model. But on the first glance, I would say that it's more concerning that because there is this notion of true or not true indeed.
For the data, yes.
Yeah.
But you see that when you see a model explain,
Yeah.
when you explain, you answer a why question. When you answer a why question, there's always something model in your explanation, something about possibility and necessity. This is beyond the strict empirical prediction. It's something you believe that the model captures something about causal link in the world, or real stuff, or if you were a real positivist, okay, it's only empirical period, you would even be uncomfortable. So, can I explain with model? I'm not sure. I can fit the world. Maybe it's enough.
Okay. Yeah, because indeed I go through a multitude of way of goal of modeling, and then indeed I should focus on the one that I will be interested in for sure when I'm seeing.
No, I'm not discouraging you. If you were capturing everything about the model with value something, it would be great. It would be much more metaphysical than ordinary Peter stuff, but you can go beyond the master.
I'm not sure.
Kill the father.
And because there is like the project would be more in a standard or conservative view, like more to check, okay, are the hypotheses of the model confirmed because it's working and the empirical information are confirming a model, or the success of the model is even like confirming a certain degree of knowledge regarding about target system. So maybe in one of those views I would describe myself more. That's already maybe a way to make more precise, like where can this supervaluationist thing
where it
be?
works best in the project.
How does it work? Where? Okay, thanks. And I think indeed the view that are mainly, so at the end I was like having quotes about from Katzaf too, and the main quotes that were like giving a bit of a supervaluationist vibe. I don't want to say it this way, but that was linked. Was the standard view, but then also the possibilist view.
I'm not sure I understood the possibilist view because I don't know well this guy, but it looks more like idealization than approximation, the possibilist view, which is interesting.
Okay, but thanks a lot, Alexandre, for your comments.
Other questions or comments?
The last one there is related to something I wanted to pick up on, and actually we came over it a little bit as well in the response to Max. Another thing that I think this relates a bit to this idealization versus approximation, and it's another kind of ball of difficult to disentangle concepts. But I think you're going to have to figure out how to get clear on ambiguity versus vagueness versus uncertainty versus etc. And I mean, partly I am fully well aware because I've written on this. You didn't present it clearly because no one presents it clearly. Like literally no one. Like the entire literature. There's no consensus way to define these things, right? It's a total mess. Some things that some people say are ambiguous, other people would call them vague, and vice versa. Some things that some people say are uncertain might be ambiguous instead of uncertain, or I mean, this whole thing is a mess, right? There are people who some people have presented definitions of all those words, but none of them receives general approval. So, yeah.
I read the paper of Baylor Jones. It's the only things that everybody say, okay, that's a good paper in this literature.
Yeah, I had this like ugly footnote in that paper I wrote, right, where I was just like, I'm just going to use these two words and pretend like they mean the same thing, and then I'm just going to not use any of the other words, right? And I mean that's not good philosophy, but sometimes you have to do that. Here I think you're probably going to have to say, okay, what I'm trying to target is X phenomenon, uncertainty in modeling, whereby uncertainty I mean exactly blah. And then you can have a long footnote where you say, of course, you people, you could mean other, my readers, you could mean something else if you want. But like for my purposes, I am stipulatively defining this concept as blah. I think you're going to have to do that because otherwise you're going to run into exactly some of these worries that we were bouncing off of earlier, which I think in part are worries that are just because these terms don't have fixed meanings, So yeah, it's a mess. But it's not your mess, but you have to clean it up anyway. Yeah, so that would be my main. Well, in addition to, I had some similar stuff about models and the empirical and stuff like that. We had the same worry, but my other main worry was about this.
Yeah, I think the only way I saw this difference between vagueness and ambiguity was indeed, I think, in the Solid Paradox book, where they were saying, oh yeah, no, ambiguity means something else, and then assumed it was indeed that, but then it's just a point of view, a way to define it, I'll have to be careful about that.
Yeah, I think there's nothing for it but to invent your own set and just say them very clearly. And everyone will know why you've done it, because anyone who's read in this literature knows that there's no set of accepted definitions.
Okay, thanks a lot. And that now it makes sense that. So I quote one of your article in my thesis project, and I was like, Charles uses ambiguity. Interesting, but then it makes a lot of sense. Maybe it's this one that you have a footnote.
Yeah, no, I just dismissed the whole problem out of hand. I was just like, I know it's a mess. I'm sorry. I just tried to avoid the issue,
Okay.
and I think I could get away with it in that context because I had a precise target, but a conceptual target. But you're doing something much more general. So it's not, if you were only talking in the whole thesis about one phenomenon in climate models or something, then you could probably get away without doing it. But if you want to say something more general about, what can supervaluationism bring to modeling? Well, that you're going to have to say exactly what feature of modeling it is that is the problem, and that's just going to be stipulative definition.
Thanks a lot.
Yeah, so don't be afraid of just inventing your own meaning for defining that term yourself.
Other questions or comments? Victoria?
About this, I made with Peter a kind of glossary about what is uncertainty for me, so I can send to you.
Oh, cool.
Okay. Nice. Thanks.
A tiny question about really detail when you were talking about Poznik. What is this objective imagination? This seems really strange. I don't see how it is objective, but you passed quickly on it, so maybe.
Okay, perfect. I haven't read that much about objectivity yet. This is the way he described it. But so fictionalism is defending, it's here, is defending that you have some kind of fiction that are more private, I would say. Let me reuse the good term. Yeah, some more private games, and then models or more objective imagination, so something fictional. So that's the way it's defined. Does it make it objective? That's maybe another question, but because it's used by a lot of person and a whole community and it stays in time, it's defined as something more objective than the game you just make and invent yourself. And for a bit more of information, in those you really see the scientific game as a make-believe game, like make-believe in French we would say faire comme si or something like this. And then here it's really the difference with just a game that you play as a child.
But usually, I don't know if he quote, they all refer to the same philosopher of art that wrote about make-believe.
Wenton?
Yeah, Wenton.
Yeah.
So it's a very precise notion of a certain
Fictionality.
specific way to do a game, which is an extension of what we do when we are children.
Okay.
The
So
reason Walton says when you go to see an horror movie, you're not going outside of the room screaming and running, but you still fake for yourself fears. But he's a philosopher of art. He's not writing at all about it. But the source of Frege and all these guys, it's this Walton, because they say that's the way scientists are just children, continue to invent stuff with more constraint. And so it's not necessarily a representation. Could be anything.
So okay, and if you want to know the difference between Frege and Thun or Thun?
I think it's Doom, but that could be. I never met him. I
Yeah.
met Romanov, but I don't know
Whether he's Dutch or not.
Yeah, I should check.
It's been a long time. It's been a long time Roman has been here, so we should invite him.
I would be glad to. Yeah, that might be nice.
Yeah. It's not far.
And so one is saying that you have access directly to target system when you're modeling or doing a model, and another one is saying you have a model system between your model and the target system, and there comes all the critique of Pozniak from there regarding this access to target system. But so objective.
I'm not convinced, but
Another question to ask. And then maybe I can try to address Marco's first question when he was saying, okay, you can take it as a more as a question more about the computational model. Because he was asking if you can have run a computational model and end up with different results. Well, in the way Weisberg is describing it, which is really that it's like the explanatory power that is interesting, and here that it's the algorithm and the transition rule that is really giving this explanatory power. I could not say if you can have different results, maybe it depends on your model or your computational model, how you build it, but then this is not what Weisberg or that kind of typology of model is interested in. If you end up with different results or not, that's not the question. It's more about what is the structure that is making, that is reasoning about, what is this algorithm that you run with? I'm sorry if I'm not using the right word in science student for us. So I don't know if it's going to answer perfectly to his question, but maybe an opening regarding that.
Other questions or?
Yeah, I have a question again about this parallel between robust models and something like super truth. I was just first, just more for the clarification. The idea is that the correspondence is between, so as I understand the case of supervaluationism, the idea is to treat the sentences like this is a heap or this is not a heap. And in the case of model, what will be like the target? It will be the predictions, or like what it will be with the sentences, like I don't know, the temperature, I don't know, the global temperature year X will be this, or it is something like more general predictions, or it's something like now we understand the climate.
Yeah, that's the empirical, non-empirical again.
Yeah, that's empirical, non-empirical. I think it's also again what you said about idealization and approximation, because if it's only about sort of prediction in numbers, it can be treated as approximation. But if it's idealization, indeed, then it's, as I understand idealizations, it's something less empirical and about something else.
Okay, and can you remake the comparison you made with it was with the heap and the prediction?
Yeah, because for me, I don't understand, like, the analogy, I don't understand it, because it's not made yet. But I was just curious whether it's, so the correspondence should be, so as I understand supervaluationism, it is invented to deal with sort of sentences like, this is a heap, this is not a heap, this is, I don't know, red, this is orange, this kind of stuff. And for this, we can say, okay, it's super true that this is a heap, it's super false that this is not a heap, and for something in between, there's something in between. But what would be the correspondent of this in the case of robustness? Because it seems to me that sometimes people talk about robust predictions, which will be empirical content, and people say, okay, it's robust that this will increase, or it's robust that it will be around, the value of this variable will be around 25. Or sometimes it seems to me that, I know, not in climate science, because I'm talking about climate science, for example, in biomedical studies, people say something, okay, it's a robust finding that this mechanism is involved in this process. I don't know if it's the same as predicting an outcome or not, or maybe, yeah.
Okay. Yeah, I like your comparison between heap and a prediction. Or maybe it can be applied to a result in general, I would say. Maybe but again, it's asking for the question of the goal of the model. Do you want prediction? Do you want to run it to, just compare the results you have with the empirical information you have? But yeah, for me, that would make sense to compare the two. And it's already making it more precise without a bad joke, but of where I could see this comparison. But it's not super clear yet, indeed. But indeed, in the end, the thing that is unclear or that is vague is. But your prediction is not especially vague. You can have different ones, or they are not always saying the same. Maybe the prediction can be a lot of precisification and our way to make it more precise, and then in those you check if there is something that is being made precise in the same way. But does it make it the heap, or does it mean that it's more like it's more the thing that you want to model that is the heap, that is the thing that is vague and you want to make more precise. But maybe this is really not how I can talk about it. Like, I don't have all the vocabulary and the understanding yet. Or do you want to try to reformulate?
Because I'm super confused about this question. So,
because you're really going to the thing that is the less clear in the project so far, which is like, how do we apply supervaluationism to those problems? But indeed, at one point there is like this intuition or this common thing. So I should indeed make it clear where I see the comparison and how to begin somewhere.
Yeah, because if we go back to this sort of distinction, where is this uncertainty something comes from? It seems to me indeed that so sort of superficially it's analogous, because in the case or not. So in the case of climate models, we will agree that it's after some time it will be like the parameter we're predicting, it will have some precise value, and it's not sort of, it's similar to the case of the heap. I think that like in the case of any heaps or not heaps, we'll have a precise number of grains, but then it seems to me that it stops being at least superficially analogous, because in the case where people are just interested in applying a predicate to the different things, and here it's not about, it's about prediction. So yeah, I know how to make an analogy.
Historically, the supervaluationism was used, one of the first applications of this logic was to deal with open future,
Yeah.
also on prediction, also notably in Thomasson paper, supervaluationism, interpretation of Aristotle on Bigfoot's position, on Occamist position. So there is a bridge because the first vivid application was indeterminacy, but indeterminacy has many flavors. One is vagueness, another open future. And today there is a kind of supervaluationism, very weird. I don't understand where the stuff. It's the Blandine theory of stability. Rudely, it's supervaluationist in spirit, and they use that for vagueness and future. But I don't understand the story. It's Blandine, so I don't understand how they speak this story with other logicians. I don't understand too. But he uses he has an intuition about the stability of meaning and stability of but it's very close to supervaluationism.
That was the bell. So
Yeah, we started a little bit late, but I think it's okay. Okay, just a final comment under the, of course, the authority of your promoter. It's true that you arrive in a debate that is 50 years old, the epistemology of model, and it's a complete mess. So maybe to orient yourself, to read a little bit the founders of this approach, even if it's not up to date, Van Frazen, Supes, and Margaret Morrison, because it's her that attacked the traditional epistemology of model and is the source of all these based on practice. It's model as mediator. And it helped me a lot to situate myself in the crazy literature now, because okay, the goal to talk about models was blah blah blah. It's why philosopher introduced model. It was very clear in Van Frazen and Supes and in Morrison. They said this is a part of how science represent the world that was not taken into account when philosophers were talking just about theory. So there was a goal to the thing. It's not just, oh, they use the word model, it's cool. Today it looks like that. But let's check how many ways scientists can use models, and as you saw,
Yeah.
Wi-Fi is going crazy.
Okay, amazing. Thanks
so
a lot,
maybe
Alexandre.
to come back to why it was introduced in philosophy,
Definitely.
it helps.
Thanks.
So let's thank our speaker.